What's going on, guys, and welcome back. In today's video we're gonna talk about Snort, and also before talking about Snort we're gonna cover some basics. So if you know what is Snort or you have some basic understanding about Snort, you can skip the introduction now. If you don't know what is a Snort and you would like to get familiar with the Snort, it's very recommended to stay and listen to the introduction, as I will go over some terms that will ease out the process of comprehending the operations of Snort. So basically, let's first start with what is an IDS. So IDS stands for Intrusion Detection System. So Snort can operate as an IDS and can also operate as an IPS, and can operate actually both as an IDS and IPS depending on the configuration. Okay, so an IDS, what an IDS does, it actually alerts you when there is a pattern in the traffic that matches the rules. So basically IDS, IPS, NIDS, NIPS, all of these terms, actually all of the IPSs or IDSs work based on something called the rules. Okay, so in the rules we set a file. Actually rules are stored in a file called the rules, right? So every single one of these operates based on the rules. In the rules section we define what is acceptable in the traffic, the network traffic, and what is not acceptable, and based on the rules these guys do the work. So an IDS, actually what it does, it monitors the traffic, it analyzes the network, and it alerts you. So first it alerts. So let's do this. So here, let's write here IDS, right? IDS alerts you if the traffic matches one of the rules that you have configured in your file. For example, you have a rule configured in the rules that prevents or that will alert you if an ICMP traffic or ICMP request is detected. So what an IDS does, it will monitor the traffic and create an alert for you indicating that an ICMP pattern has been detected in the network traffic. So it alerts you guys, and also it can log the traffic. So we can type here IDS. So IDS alerts you and logs the traffic. Now what an IDS doesn't do, guys, is it doesn't drop the traffic, it doesn't drop the packet or reject it. The difference between drop and reject, drop actually drops only the selected packet or the detected packet. In our case, if it was an ICMP, it will drop the ICMP packet. Reject, it will drop the entire connection all at once, right? That's the difference between drop and reject. So an IDS doesn't drop nor reject, it only alerts and logs. Okay, enough on IDS. Let's talk about now the IPS. IPS stands for Intrusion Prevention System. That's the thing, it actually prevents, it has the ability to prevent the packets or the entire connection. So it can identify and block the threats with less user intervention. It's actually the same, it works based on rules, right? So when we configure a program like Snort to work as an IPS, what it does, it's gonna actually alert you, right? It can log the traffic, and you can select an action. It either drops or rejects. So as you can see, IPS has all of these capabilities, while an IDS has only the alert and log capability. That is the difference between IPS and IDS. But remember, both needs rules, right? We're gonna go to talk about rules when we take Snort as an example. Okay, so what is now NIDS? NIDS, guys, is a network intrusion detection system. It operates on your network. So basically, in the case of network intrusion detection system, it monitors the traffic flow from various areas on your network. Say your network is 192.168.1.0/24. So it's going to monitor the traffic on the entire network, entire subnet, say your corporate network or your home network. The aim is to investigate the traffic on the entire subnet. So basically the same. It has to have rules. So if a signature or rule is matched with the traffic that is passing into network or across the network, an alert is triggered. So again, NIDS can alert you. NIDS can log the traffic, but NIDS cannot drop or reject. So NIDS is the same as IDS. IDS is a concept, guys. In reality, you are configuring your, let's say, Snort either as an NIDS or HIDS, right? But in general, we say these guys are IDS or IPS. These are concepts. But now, in the real scenario, in practical scenario, it's going to either be NIDS or HIDS in case it was working as an IDS. So NIDS alerts and logs. Now, similarly, guys, NIPS, same as IPS, but on the scope of a network. So instead of actually, or not only alerting and logging, also works by dropping or rejecting the entire network. The aim here, guys, is to protect the traffic on the entire subnet. Again, when the traffic or when a signature in the traffic matches the rules, one of the rules, it's going to alert, log, and either drop or reject. That is NIPS. So NIPS has all of these. Okay, what about HIDS? So HIDS is host intrusion. So host intrusion detection system. HIPS, same, host intrusion prevention system. The same concept. The difference is that in the HIDS case or HIPS, it works within the scope of your computer, the hosts, right? So what it does, it monitors the traffic flow from a single endpoint. So say 192.168.1.5 is a web server on your corporate's DMZ, and you configured Snort to work as an HIPS. So what this Snort is going to do is going to monitor the traffic only on this web server and alert, log, and either drop or reject when a pattern in the traffic matches the rules. Most importantly is the rules, guys. So these are the terms that you need to understand if you don't know what is a Snort and you are not familiar with these terms. So now let's here open a new page. Okay, and now we're gonna explain the detection or prevention techniques. So let's go back to IDS, IPS, how these guys work. Yeah, I know we have rules, okay, file. In this file, all the rules are written, and if the traffic, one of the traffic or traffic pattern matches the rule, an alert, as you can see, is triggered, and the packet, in this case, this packet, right? Say it's ICMP, either dropped or rejected, right? That if it was an IPS. If it was an IDS, it's gonna only alert. That's it. Okay, so how these guys work? So there are three basic techniques of how prevention and detection methods work. The first one is these guys work based on what we call it the signatures. So the signatures actually, or the technique, relies on rules that identify the specific patterns of the known malicious behavior. This model helps detect known threats, much like antiviruses, right? It has a set of signatures. If a file, downloaded file or an attachment matches one of the signatures, it can tell you, yeah, you have a virus now, or there's a malware. Same in the signatures. So signatures actually are the same as rules. This is the first technique. Next one, we have the behavior-based. So in behavior-based, what happens is the technique actually identifies new threats. So here it has the capability of identifying known threats plus unknown threats. How? By training. So basically it can detect new threats with the new patterns that pass through signatures. The model compares the known, the known. So say the known traffic, right? The known malicious traffic, it will compare it with the normal behavior. So within the behavioral pay, I guess I confused you guys. Let me remove these and let's start over. So basically in behavior based, what happens, you train the IDS or IPS, right? You train it with normal traffic. So this is normal, much like TCP, ICMP, let's say, and UDP. This is an example. We tell the IPS or IDS that TCP and UDP are normal. Of course, we don't say it's literally TCP and UDP. We give it, say, period of time where it can go through all of the packets and analyze them as normal, right? Normal behavior. And then we can feed the behavior based here something called the abnormal. For example, FTP. Say FTP is not permitted in your network, so you feed some FTP traffic to the behavior based IDS and you flag it as abnormal, and so on and so forth. What's going to happen in the future is that when the traffic passes through your network and the IDS says that, yeah, this traffic actually is normal, I'm not going to say anything. So if it sees FTP, it's going to say, yeah, this is abnormal, I'm going to trigger an alert, and either I drop or reject. That's how behavior based work. It's more efficient than signature based. The last one is the policy based. So much like when we talk about the group policy in Windows. So we define what are the accepted policies and what are the rejected policies, and based on that we treat the settings in Windows, right? Based on that we actually allow the user to do something and we don't allow them to do specific thing. So this technique compares detected activities with system configuration and security policies. It resembles group policy, but not, of course, it's not the same. It operates on the entire network, not only a host. Alrighty then. Now we explained some theory about how these things work. Now let's go to Snort. So open a new page, and here let's write again Snort. So Snort is, as I told you guys, it is an IDS/IPS, meaning it can work as an IDS alone or IPS alone, okay, based on the configurations, which we're gonna talk about later. So how Snort works. So some things that can be said about Snort is that first, Snort can analyze live traffic, so live traffic analysis. So you can, for example, go to your install Snort, right, and start Snort. So Snort will work on analyzing live traffic and trigger alerts, as I told you, logs, drops if it was an IPS, or rejects live, basically. So the next thing that actually can be said about Snort is that it can log packets. So the captured packets can be logged for later analysis. Third, it can actually sniff. So yeah, we're talking about sniffing, so let's do this. And lastly, it can actually prevent threats. That's why they use it. It alerts and prevents threats by this mechanism: alert, log, drop, and reject. So that is actually Snort in concept, right? You may tell me it was very brief. Yes, basically Snort actually works in the same concept, guys. So it's an IDS or an IPS, analyzing traffic, logging traffic, and preventing threats. And of course, Snort needs, what do we call it, the rules. So let's talk about this in a new page. So open your page here, and let's talk about the configurations of Snort. So now let's type again Snort. So the first thing to mention about Snort, guys, is the configuration file. First, when you first install Snort, you have the config file. The configuration file, what does it contain? It contains the path to rules. there are certain parameters that do exist in the configuration file, among which is the path to the rules. Next, the plugins. It contains the plugins. You can install plugins and point them in the configuration file. It contains also some variables such as the source network, or we call it the home network, SourceNet. SourceNet is the network you're trying to protect. Also, we have the external network. External is the network that we would like to monitor. So basically, it defaults to, the external is not the network we're trying to monitor, it's the external network, the network outside our network. So it could be home, right, or anything. Here it should be any. The Snort configuration file is located under /etc/snort/snort.conf. This is the default configuration file, the location of the conf file. Now, the next key thing about Snort is the rules. So the rules file, normally, it is located actually under /etc/snort/local.rules. These rules, or this location, actually is defined in the configuration file. If you want to change or when you use some other rule file, it's recommended not to change the default location in the configuration file, but it's actually but to indicate that explicitly while you run Snort. We're going to talk about how to use different configuration file later down in the video. Okay then. Now open a new page, and now let's see how we can start Snort. So it's very important to understand that Snort works in 3 modes. The first one is the Sniffer mode. Sniffer mode. The next mode is the packet logger mode. It logs packets. And the last one is the NIDS/NIPS. Okay. Alright then. Now we're going to talk about every single one of these and how to operate them. So let's first start with the Sniffer mode, okay, and do this practically, right? So enough theory now. Let's now move to the practical part of this video. Alright guys, so to demonstrate the practical part of this video, I found this room in TryHackMe. It is about Snort, and there is a machine here with task exercises. We're gonna walk you through how to use Snort in all the modes, the Sniffer, the Logger, and the NIDS or IPS, and how to use Snort in that fashion, using practical examples in this room. Okay, so let's first start with the Sniffer mode. So in the Sniffer mode here, if we scroll down, there are no questions to ask, but let's first understand how this works. So open the task exercises. In here you have traffic generator and exercise files. The traffic generator actually is a script dedicated to generate traffic. So without traffic, Snort won't work. It needs actually traffic to be able to analyze it. So we're gonna generate the traffic and first work with the Snort as a sniffer. Let me open my node file here and see the Sniffer mode. Scroll down, scroll down. Let's see. Okay. So this is the Sniffer mode here. Let's first start some traffic, or let's first open Snort. Make this bigger, zoom in. Okay, is this fine? I guess this is fine. So cd desktop, let's cd task exercises, and off we go. So here we are. So we have the traffic generator. Before we start the traffic generator, guys, we're gonna first start Snort in Sniffer mode. So sudo snort, and we point the configuration file first, -c we define the configuration file. In this case, it is etc snort.conf. So this is the default configuration file. Now, if you go back to my notes here, scroll down. Okay, so as you can see, for Snort to work in a sniffer mode, we have different options. We can either sniff the packets in verbose mode, okay, where the packets that are being captured will be displayed in the console, or we can use the -D for more details about the sniff traffic, or we can actually use -E. The -E will display only the link layer header data. And we have full packet dump mode, which will display all of the details about the packet. Let's first start with the verbose mode. So -V. And before doing that, or let's enter. And as you can see now, error quitting, unable to open rule files, no such file or directory. So the default config file actually is located under etc snort.conf. Did I use different config file? Let's go back. It's without IG, so conf. Yep. So now actually Snort has started and it's ready to capture traffic. You see all of these, all what's happening now, actually traffic being captured on the network. I know I haven't started any traffic yet, but this is what's happening right now on the network, and it's being captured by Snort. As you can see, these are the packets. We see it in verbose mode. We see everything in real time. Okay, so instead of doing that, what we can do, we can stop Snort and say -D. Take a look at this. So in -D, scroll down. Let's first generate some packets. ID, new tab. Zoom in. Okay. So we have here traffic generator, sudo traffic generator. Let's select to generate some ICMP traffic and click on OK. You see now the ICMP traffic actually is being generated. Let's click on X and start Snort with the option -D and then start the ICMP traffic. Okay, ICMP has finished, and now let's stop this and take a look at the captured traffic. So these are TCP. Let's see if there are some ICMPs. Go down, go up, scroll up, scroll up, scroll up, scroll up. I know this is not a practical way of viewing the logs, but just I'm trying to demonstrate the difference between the sniffing modes, guys. So in a nutshell, -D option, the -D option, as you can see, it dumps the packet data, right? For example, let's take a look at this one. These are actually the data of the packet. You won't see these in the verbose mode that we talked about previously. So the verbose mode dumps the captured data, but -D with more details. You can view the full dumped data of the packet, of the payload. Let's talk about other sniffing modes, guys. -E, and we have -X. So again, let's type now without D -E. It will only grab the header of the packet. Let's take a look. You see now there is no any data being dumped right from the packets, or there is no any details about the data contained in the packet. We only see headers. So if you exit now, so in the header, as you can see, we see only the IP address, the source IP, source port, destination IP, destination port, the protocol, time to live, and other details. These actually are contained only in the header of the packet. So you only see the header of the packet in the -e mode. Okay, so -x will provide full packet dump mode. Let's take a look at this. So -x, what's gonna happen? Right, you see the difference? Take a look at this one. So with this one, you see the full dump of the packet. You don't only see the header, which contains the source IP and destination IP, you also see the packet dump, the data contained in the packets. -x is very useful if you are doing a deep analysis on the traffic. So that is Snort in sniffing mode. Now you might be asking me, I want to sniff traffic, but I want to store this, all of the captured data, in a log file. Now come -L to the rescue. This option is used to log packets, and we will see how to use this option when we come to the packet logging mode of Snort. So simply by typing -L and defining the path, let's say at the current working directory, we're going to store the logs here. Type that L dot, and as you can see, when it finishes, let's wait a bit till it captures some traffic, and gonna exit. Checking the directory here, we see a log file called snort.log. Now if you cat this file, permission denied, okay, sudo cat snort. As you can see, the format of the file is binary. That's why you need Snort to read this file. How to read a packet captured file? So you type sudo snort-r snort. This way you are able to read statistics and information about the captured packets, in addition to the, as you can see, the packets. Pay attention that these are not alerts, right? These are not alerts. We are talking about Snort working as a sniffer, right? No IDS, IPS until now. So this is Snort in a sniffing mode and how to store the captured data. Let's talk about the other mode now, which is packet logger mode. Let's see if there are questions to answer under this task. No questions to answer, that's fine. Okay then, so going to packet logger mode. So before answering the questions of this task, let's talk about the logger mode and how we can efficiently use this mode. So we go back to the machine itself and to my notes. So the packet logger mode, guys, works by logging the packet to a file you select. Okay, so by default, if you don't specify the destination of the log file, by default Snort will store the logs under var log snort. If you're willing to specify the location, as I told you in a while ago, using -L, and here specify the path of the directory. So now let's go back. Packet logging mode, what does it mean? It means that Snort will not only sniff the packets, but will also store them under a log file, like this one. This is the command. Let's say ls sudo rm-r snort, remove the log file. Okay, now in here sudo snort, okay, and then as I told you guys, you can specify the configuration file with -c, but we're not going to do that for now. We're gonna we know that there is only one configuration file under etc snort snort.conf, so by default Snort will use that configuration file. So sudo snort now, and I want to sniff traffic in verbose mode. Okay, say I want to sniff traffic in verbose mode, and I want to store the logs under the current working directory. So let's generate some traffic now. Before selecting, let's run this, okay, and generate some hey HTTP traffic. Okay then, let's wait till the generation finishes, and we're gonna investigate the logs. Okay, just gonna stop Snort now. Stop ls. So we have one configuration file. We're gonna read this configuration file with the snort sudo snort-r snort. Yep, read me the configuration file. This is the output. Let's see if there are some HTTP packets that have been sniffed. These are TCP. Let's scroll up. We can use grep, by the way. Let's use the filters. So we can use the filters here. So here, hey HTTP error. Let's see how I can filter the logs when I read the when I use Snort to read them. So -n. So here, as you get -r, the log name, and I specify the protocol. That is what I did, but did it work? So no HTTP, okay. So port 80, and we got some results. So these are the HTTP traffic. As you can see, the destination port is 80. Right now, what if I want more details about the nature of these packets? What I would do, I would go back, sudo rm-r, reload the current configuration file, and then run the sniffing. Go back. So instead of -v variable mode, I'm gonna run the sniffing in full data dump mode, -x, and log everything under the current working directory. Start, generate some traffic, HTTP traffic, tell it okay, and let's see. Okay, back, stop, ls. Let's now read the configuration file and use single quotes, type port 80 to filter for HTTP traffic. What happened? Oh, so the file is different now, file name. And wait. I guess I removed the configuration for the log file, right? So sudo snort -r, read the configuration file, and display the port or HTTP traffic. Let's see. Yes, but I want to see the capture data in dump mode, so I'm gonna rerun this. -x and rerun the traffic generation. HTTP. Yeah. Ls sudo snort -r snort port 80. Okay, seems like we don't have much details about the captured traffic to view with -x. Okay, but anyway, these are the captured HTTP traffic. Okay, so now we talked about the logger mode, sniffer mode, and how to read the logs. Still, there are additional things to mention about the logger mode, I guess. Here -k ASCII, if you use this one, you can actually capture the traffic and store the logs in the ASCII format. So this file has been generated in binary format, and without Snort you won't be able to read it. If you want to generate a log file that can be read, you can use yeah, so -k ASCII, right? We can use -dev here, I guess. So -dev, so -dev -k ASCII. This will capture the traffic, sniff the traffic, and log the captured traffic in a file readable by a human being. Let's see. Generate HTTP traffic. Okay. Let's take a look at this. Now we don't only have this binary or the log file in binary format, we have it also in human readable format. Now if you go to one of these IPs, these are the IPs that have been captured in the sniffing mode. So CD 192.168, let's go to this IP address. Permission denied. Okay, sudo chown 192-r. What is the username? Ubuntu. Okay. I need to give myself permissions. Ubuntu on 192.168. Okay, CD 192. Okay, so we have one log file cat ICMP. As you can see, it's human readable, and since I use the -x mode to perform full data dump of the traffic, I can see the data of every single packet. I hope the logger mode and the sniffer mode is clear. Let's do now the exercise here. So there's an exercise with some questions to answer. Okay, so investigate the traffic with the default configuration file with ASCII mode. This is the command. Execute the traffic generator script and choose task 6 exercise. Wait until the traffic ends, then stop. Okay, so what's gonna happen? We're gonna start snort here in, guess what? In the packet logger mode. I guess I'm gonna have to remove all of the mess here. Sudo rm-r snort. Remove this. And remove all of the files that starts with 1. Now everything is clear. Sudo rm-r packet. Okay, so let's generate some traffic now. Before doing that, we're gonna start snort now in C. This is in what? Logger mode. It's gonna log traffic and store them in ASCII mode in the current working directory. Start. And now let's generate some traffic according to the instructions in the exercise. So sudo traffic, and here task 6 exercise. So select task 6 and okay. Task 6 packets will be generated and snort actively will be able to capture them. Yep. Okay. ls. Now we have, as you can see, these configuration files. Log files. Let's go now. Now you should have the logs in the current directory. Navigate to the folder 145254. CD 145254. Again, permission denied. You have to change the ownership on these configuration files. Yep. Okay, so we have these captured traffic on these ports. So on port 53, DNS 80, 2 HTTP packets and 1 DNS packet. Let's go back. Now you should have the logs. Okay, what's the source port used to connect to port 53? Going back, the source port used to connect to port 53, it is 3009. Answer. Use snort log 16400. Let's see if we have this log file. Guess I don't have this file. Use snort. Read the snort log file with snort. What is the IP ID of the 10th packet? Now, unfortunately, I don't have this file or log file, but I'm gonna generate it. Let's remove these logs first. Okay, now this is a snort. Oh, yep, that's why it didn't work, because I haven't stopped snort from capturing the traffic. Very importantly, guys, before you analyze the logs, make sure snort is stopped. So let me rm1 Okay, and now let's start Snort one more time. Okay, task 6. Yep. Just for the sake of generating this log file, by the way, we're doing this from from scratch, or starting over. Okay, finished Snort now, and ls. Where is the Snort configuration file? I guess I'm gonna have to look for this file. Sudo find dash type f dash name to dev null. Nope, there is no such file. Okay, let's do this. Remove these and type this one. No. Look where it is. This is the file. So let's now cat this file, or use Snort to read this file to answer the question. Sudo snort dash r dash n. Then we'll read the first 10 packets. Okay, what's the question now? Quickly. Okay, what is the IP ID of the 10th packet? This is the 10th packet. Where it is? This one. The IP ID is this 49313. Okay, read the Snort, the same log file with Snort. What is the referrer of the 4th packet? Scrolling up to the 4th packet. So 1 packet, 2, 3, and 4. What is the referrer of the 4th packet? This one is kind of tricky, right? There is no referrer here, guys. I guess. Well, read the file with the Snort. What is the referrer of the 4th packet? I answered that question, but I don't know how to find it again. So, 1st packet, next, 3rd, 4th. Where is the referrer? So how did I find the answer to this question now? I cannot remember. Eight zero zero four. Somehow it was there. Okay, read the Snort file with the Snort. I'm gonna come back to this later. What is the acknowledgement number of the 8th packets? So the 8th packet, this is 10, this is 9, this is 8. This is the acknowledgement number, FFF3. That's right. Read the Snort file, and what is the number of the TCP port 80 packets? It means how many packets has been captured where the protocol was HTTP. So I guess we're gonna have to count them. So you count where the destination port is 80. So source port, this is the port 81. So port 80 is the first packet. Next 2, we have 2 now, and now we have 3, 4, 5, 6, 7, 8, 9, all of them. So here we have 10, but we're gonna have to find the total number of HTTP packets, right? So we're gonna look at the statistics tab here. See if we can grab this from here. Okay, let's read the file one more time. Looking for the command. Okay, let's cancel this and read all of the packets. So total we have 43 packets, among which how many packets have been detected as HTTP packets. Okay, so what do we do here, guys? We use the filter port 80, and they are 41, and this is the right answer. Now about this, I guess you can find this if you, what you're gonna do, guys, here, you're gonna remove the log files here, remove these, run snort one more time, but we're gonna run snort in this mode, sudo snort -x. So you're gonna be able to dump the full data packet. So the referrer cannot be found unless you dump the full data packet, where you will be able to find all the details about the packet that has been captured. Okay. Now let's talk about the IPS mode. Exit. So now we use Snort as a sniffer and as a log analyzer. Let's remove the log file first. Okay, now it's time to use Snort as an IPS or an IDS. Okay, now before we dive into the IPS IDS mode, there are some considerations to take a look before we start. So first, in IDS mode, we talked about that, and we actually said that it creates alerts and logs the traffic without rejecting or dropping the traffic. IPS, we create the alerts, logs the traffic, and based on the rules, we either drop or reject the packets. Now, note one, once you activate Snort in IPS IDS mode, sniffing and logging will be semi-passive, which means if you want to save logs in a specific format or to a different directory, you're going to need to use the options from the logger and sniffer mode. So basically, we saw that when Snort works as a logger or sniffer, it doesn't actually, the IPS or IDS isn't activated. But when you activate the IPS IDS mode, the sniffing and logging will be done in the background. It's actually being done, but you don't see it. So if you want to save the logs of the IPS to a location, use the option -L that we used earlier, this one. Here specifying a directory. I guess this is clear. Also, IDS IPS mode will generate an alert file where you can investigate the alerts. So in case the IPS or IDS has detected a match or matching packets between the actual traffic flow and the rules we have defined, it's gonna trigger alerts, right? The alerts will be stored in a file called alerts, as we will see later down in the video. Note 3 before we start, once you run Snort in IPS IDS mode, and depending on the alert mode, you will see stats about the packets and alerts in the console output. We're going to talk about the console output in a while. Okay, so how do we run the IPS IDS mode? First, before running Snort as an IPS IDS, make sure you have a correct rule file. Now, if you are downloading Snort for the first time, Snort has default rules defined for you. But if you want to add rules, you're gonna make sure that the rules actually or use the rules in your command. We're gonna talk about this, guys. So let's talk about the console modes here. Okay, so we have console mode, we have CMG mode, we have fast mode, and we have full mode. Also, we have no alerts. These modes actually control the alerts and how they are displayed when you start Snort. For example, in the console mode, okay, the alerts will be displayed in a brief manner, meaning that only the payload header is printed. Let's take an example, guys, without just overflowing you with theories. So in the exercise here, investigate the traffic with a default configuration file. Default configuration file is the file that comes pre-configured when you install Snort. No need to modify on this if you don't have rules created by your team or by yourself. So let's do the task 7 exercise now. So we're gonna go back, clear, and what we're gonna do here, we're gonna open a new tab. I'm sorry guys, but the shortcuts for zoom in don't work. That's why I'm using the menu. Okay, 1 2 1 2 1. Okay, so in here we will start Snort in an IDS mode. So take the command and I will dissect the command for you. So sudo snort -c, we specify the configuration file. Very important to specify the configuration file when you want to run Snort as an IPS/IPS mode. In here, based on the configurations defined in here, Snort will act as either IDS or IPS. -a full means that the alerts or the packets that trigger the alerts will be displayed in full details along with the alerts that have been triggered. -a will create log file and save it in the current working directory. Start this now. Now Snort is working as an IDS. Let's generate the traffic appointed to this task and choose task 7. Okay. Traffic being generated now. Snort will work on, right now Snort is monitoring the traffic, right? And will store everything in the log file. So Control C now, finished, right? The traffic generation has finished, and we can use ls. This is the, as you can see, we have two files. This is the log file, and this is the alert file. If you cut the alert, you will see all of the alerts that have been generated. These are the alerts, guys. It means Snort has found some packets that match the alerts we created in the rules file. As you can see, let's take one example. This is an alert. We see first the message. It says ICMP packet found, and we see also the source IP and the destination IP address and some information about the packets. Okay, this is the alerts file, ls, and this is the log file. What's asked here? What is the number of detected HTTP GET methods? So in order now we have captured the traffic and we analyzed them, and we knew that Snort has found some traffic that matched the rules we created. That's why it generated the alerts. Now we want to know what happened, right? So we're gonna start analyzing the alerts by using the log file. So sudo snort -r, and now the question is saying, what are the number of HTTP GET methods? So in the while reading the log file, we're gonna need to use the filters. So in the filters, we use port 80. Okay. Okay. So what do we have here? 0000. Okay. Seems like we actually did it wrong. How about HTTP? I guess we're using the wrong filters. What's the number of, let me go back to my notes, reading the file. So -r, the log file, and here we use the filters. Okay, so TCP and port 80. Again, we have zeros. Well, let's try with the alert file. So cat alert rep get. Nope. 80. Okay then, so when we stop Snort, guys, we see here we have two files have been generated, the alerts alert file and the log file. Now you know the drill about the log file. Now the alert file actually is the file that contains the alerts that have been triggered. Okay, when you stop Snort, you see some statistics about the packets. So let's first go over the stats here, starting from this memory usage, packet input output. Okay, breakdown. So here we see the number of packets. For TCP we have 2,967 packets, IPv4 packets, all the packets that have been captured. We see also 170 alerts have been generated. It means we have 170 packets that triggered alerts. Nothing has been blocked or replaced. All the packets have been allowed to pass. Scroll down, stream stats, UDP sessions, HTTP sessions, and here you see if there are HTTP packets, you will see stats about these, post methods how many, get methods how many. So the question here is that what's the number of the detected HTTP get methods? Well, we have two. You can practice the rest of the parameters by using the detonator script. So this is for the questions. Let's get back to some modes. Now we saw now how Snort can operate as an IDS. So it captures, analyzes the traffic, and eventually if there are alerts, it will create them in a file called alerts. And when you stop Snort, you will see the stats about the alerts, stats about the packets. If you want to view the alerts now, you can cat alert. Now we can see all of the alerts. Alerts about ICMP packets, right? Now most of the alerts have been generated for the ICMP, and the reason is that in the rules file, if you let's go to the rule file. Good idea, right? etc snort local rules. Nope. Let's check where is the default configuration file or the default rules file. So it's under rules. Let's cut this file. What do you think? And see the alerts in there. So as you can see, we have only one rule file. We're gonna go over the rule structure, but for now, just understand that the alerts that have been generated were only about ICMP. The reason for that is that in the rules file, we have only one alert or one rule. This rule actually generates an alert when there is an ICMP packet detected in only one direction, from the source, from any machine on the network to any machine on the internet. I'm going to explain the rules in a while, but that's why you only see ICMP alerts. Now, based on this file, you will see the alerts here. Okay, so now that's Snort in an IDS mode. How about Snort in an IPS mode, prevention method? Now, we talked about the detection. Let's talk about the prevention. So, to activate the prevention mode, where am I? So, prevention, now, prevention mode. In prevention mode, there are some options that need to be activated once you start the command. The options are, as you can see, -q, -q, -DAQ. DAQ stands for data acquisition. Okay, AF packet is the mode of data acquisition. These are found in the configuration file of the Snort. And at least you're gonna need to specify two interfaces, Ethernet 0 and Ethernet 1, -A console. This is for the output mode of the alerts. So -A console means that the packets, brief information about the packets that trigger alerts will be displayed in the output of this command. -A console, and most importantly to note that this is how you start the IPS mode. Okay, now let's take a look at the IPS modes in the configuration file. So we go to the configuration file. Okay, go to the configuration file, nano, no permissions, right? Okay, this is the configuration file of Snort. Now I want to show you here, guys, some stuff about the configuration file. Here, this is the home network. It is actually written as any. It means that any network is considered as home, and it's going to monitor all of the network you specify. Basically, all the time, just replace any with the IP address of your local network. Leave this one as is. Okay, leave these as is. Scroll down. These are the ports to monitor for HTTP. Again, here we're talking about the ports. I'm trying to find. Okay, so what do we have here? Rule path. So in here, this is the path of the rules. You can store the rules you create under this path. I mean, try to minimize the modifications done on the configuration file to prevent any fail or crash. Okay, scroll down. Let's see here. What else? What else? Okay. No need for these. Leave these as is. Processor. Let's now search for AF packet. One. Okay, so here we configure actually the IPS mode, or you configure Snort in IPS mode. Now I don't think there is exercise on that, but I'm going to explain this here in a while. So basically, guys, as you can see, these are commented out. It means now Snort doesn't work as an IPS. If you want Snort to work as an IPS, you're going to need to comment out these. Remove the pound character. So we have the config DAQ, or data acquisition. This is the variable. Remove the comment from here, and here the type. From the type, you can select one of these: pcap, AF packet, dump, NFQ. Now I have explained the difference between these in my notes. So basically, AF packet, it's inline mode, and pcap, it's sniffer mode. So it's preferred always to use the AF packet, guys. So you can use AF packet as a value for this variable. Okay. What do we have else? These are the data acquisition mode, log directory. You can specify these here. So the mode if you scroll down, you see for the mode, guys, you have options: read file, passive, inline. All the time when you configure Snort, the most preferred method is to use the inline as a value for the mode. Now this is directory, and lastly we have the variable. As you can see, you can arbitrary name, you can specify any name from here, and once you specify the mode and the type, most importantly these two variables, you can comment this out, and let Snort start working as an IPS. Okay, now all of these actually notes can be found in the channel membership. You can get the notes or online access to the notes by subscribing to the channel membership. Okay, let's see, do we have any tasks or are we finished? So PCAP investigation. All right, so here we can use actually Snort also to read captured network packets or captured files. So basically, if you use Wireshark to capture network traffic and you analyze the file with the Snort, you can use Snort as well. Let's accomplish this task. So ls mx pcap, where is this file? cd exercises, I guess. Now we are at task 8. So cd task 8. And there you go, we have these files. Okay, so investigate the mx1 pcap file with the default configuration file. Let's take the command, I'm gonna explain to you. Paste. So sudo snort -c, here we specify the configuration file, -a full, and -l we log everything in the current working directory, and -r to read the pcap file. This will tell Snort what to do. It's going to actually analyze the pcap file, okay, according to the configuration file, generate the alerts in full mode, okay, and store the logs under the current working directory. Let's see this in action. Okay, finished. What's the number of generated alerts? Again, the stats about the alerts, the packets can be found when you finish running Snort. If you scroll up, oh my god, I think I'm gonna lose my voice after this video. So the alerts, let's scroll up, see the number of alerts. So we have 170 alerts. Answered. Keep reading the output. How many TCP segments are queued? Scroll down to see the TCP segments. So TCP segments queued are 18. Keep reading the output. How many HTTP response headers were extracted? Again, here are the stats about the HTTP. Now, HTTP headers. Where is that? How many HTTP headers, response headers extracted? 3. Investigate the mx1 pcap with the second configuration file. Okay, so now we're going to use another configuration file to investigate the same pcap. This will actually, what's going to happen here, guys, is that Snort will use a different rule set to analyze the current pcap. So basically, number of alerts will change since the configuration file changed. Okay, what's the number of generated alerts? Scroll up, and we have 68. Investigate mx2 pcap with the default configuration file. Again, we go back to the default configuration file. I'm gonna leave these to you guys. Very easy. The same way we analyzed the first file, you can go on with these files. Again, take 2 seconds to view the answers before I jump to the next one. Okay, enough. Now we're gonna see the rules. Okay, the rule structure. What do we have in here? Use task 9 pcap. Write a rule to filter IP ID and run it against. Now we're gonna see how we can create rules. Task. This is task 9. So task 9, it has rules, right? So here we're gonna write our rules, and based on these rules, we can analyze the pcap file. So sudo, do I need sudo? ls-la. No, I don't need sudo, so nano local. This is my rules file now. I'm going to create the rules based on the questions here. And while I write the rules, I'm going to explain the structure of every rule. So the first one, write a rule to filter IP ID 35369 and run it against the given PCAP file. What's the request name of the detected packet? Let's first write a rule where Snort can rely on to analyze the given file. So first we start with the word alert. We want to alert, right? So first we start with the action. The action can be alert or log, reject, or drop. So since we are working as an IDS, we're going to use alert. So any, source as any, destination as any, and we use two arrows to indicate that we are filtering the traffic in a bidirectional way. Again, any. Source IP, destination IP port, source IP, source port, destination IP, destination port. Okay, and let's see here. To filter IP ID 35369. Now I have all of these actually written, so I'm not gonna need to copy and to write from scratch. ICMP traffic. Let's take this as an example. Let's see if I have the IP ID here. Do I have this one? Okay. Back. Let's remove this one. So, since we're talking about an IP protocol, we're going to specify the IP as a protocol here. And the message here, you can customize the message, IP ID found. This is the message part. SID part, note that all of the alerts that you create need to start with the number 1,000,001, and you can increase the number when you incrementally when you increase the number of rules. The revision actually can start from 1, it's the revision number, so you can start from 1 and increase the number for every single rule you add. So now here we want to alert based on the IP ID 35369. So we come here, we're going to need to add a section to filter the IP ID. So ID and paste in the number and add semicolon. This way we filter for the IP ID. Okay. Save. And now we're going to analyze the given PCAP file. The given PCAP file will use the rules that we created here to filter for IP ID that we specified. So take this command and run it. Question: what is the request name of the detected packet? What happened? IP bad protocol? Really? Come on. So this one, ICMP. Nope, I guess it's TCP here. Let's save and run. What's happening? Alert TCP any 35369 35369 protocol is TCP. No idea why this is not working. Okay, let's type with ICMP. Okay, so we have one alert, as you can see. Let's view the alerts. What's the name of the requested packet? It is timestamp request. Okay, sometimes reading rules and creating them can be tricky, guys, so just pay attention. Create a rule to filter packets with the sync flag and run it against the given PCAP file. What's the number of detected packets? And now you have to change the rule. Now the local rules, and here, since we're talking about TCP synchronization flags, we can change the protocol to TCP. And here, change this to flag and type S. Okay, now here type TCP sync found. Okay, let's try now. Let's remove the current alert file. Snort. Okay, run now. Snort. Unknown option flag. I guess today I'm making too many typos. Let's see what is the word for a flag? Ah, it is S. I forgot the S. So here you have to type S. Yep. Okay. Now, what's the number of detected packets? How many packets have been detected and generated alert? We have one. So one. Clear the previous log and alarm files and deactivate comment out the old rule. Write a rule to filter packets with the push acknowledgement flags. Okay. So nano local rules and change on this. So here, since we're looking for two combined flags, push and acknowledgement, we're gonna write both beside each other. So push acknowledgement, right? Yeah, that's it. RM alert, RM snort, rerun. Okay, what's the number of detected packets? 216. Again, create a rule to filter packets with the same source and destination IP. This one is tricky, guys, so pay attention to this one. Now we're gonna go back to the rule file, and here we remove the flags. In order to detect packets with the same IP address as the source and destination, we're gonna type here same IP. That's it. So type here same IP found as a message. And again, we're gonna remove the old files and generate. Okay. What's the number of detected packets? 3. So we have a problem here. There should be 10. Visit the rules. Let's take a look. I guess this is for TCP. You may have to create additional rule, guys, for UDP as well. So paste, and don't forget to change the revision number to 2, increase 1 to 1,000,002, and here replace TCP with UDP and run it. And you got the 10 alerts. Case example: an analyst modified an existing rule successfully. Which rule option must the analyst change after the implementation? It is the revision. It needs to be changed every time you create a new rule, guys, all the time. Increase it incrementally for best practices. Now that was it for the full snort guide, in addition to the room. Now there are some questions here I couldn't find the answer to. Maybe you guys help me with this. So as you can see, which snort mode works similar to NIPS? So it is NIDS, but here we have 3 characters. I tried with IDS, it didn't work. So if you have some insights, feel free to comment or put your comment in the video. Again, according to the official description of Snort, what kind of NIPS it is open source, right? Or rule-based. I answered with both this and this, but it didn't work. So guys, maybe you have some insights, you can put it down in the comments. And that was for today. I hope you find that informative, and I hope you learned what is a Snort and how to work with it. And definitely I will see you in the next video.